right, good morning everyone, and thanks for listening in. Good to have a little sound check here. um, all right, so my name's Etienne. I'm the SVP of Engineering at Gradle and Develocity co-founder. Gradle is deeply rooted in the open source world for a long time, since its inception. It's based on the Apache 2 license. By now it has more than 40 million downloads every month. And when you look at what's used when people build new projects on GitHub, they are mostly using Gradle more than any other build tool. We also have an integration for Gradle with BuildShip into Eclipse. Right? So even though we have a commercial product as well, Develocity, we are deeply rooted in the open source world. At the conference, we're a silver sponsor here, and which means we have a booth, so you're happy to come by and talk to us there about anything you want: Gradle, Maven, SBT, developer productivity, and so on. We're also a contributing member of the Eclipse Foundation, where we contribute every year, as well as keeping BuildShip active. Right? Okay, so I'll start with a question here. What do these foundations have in common? Apache Foundation, Micronaut Foundation, Common House Foundation, and also the Spring projects as an umbrella. And you will see the answer soon. Right? I'll come back to that in a few minutes, but let me give you a bit of context first. So time is precious, right? We all have more things we want to do, we need to do, than we have time available. And so it is really crucial that we make optimal use of our time to have the most impact and to be the most happiest. And I'm primarily referring to work here, but I think it translates also quite well to private life. As developers, we are most productive and also happy when we are in this state of flow, right? When we're fully immersed into what we're doing in the task at hand. That's when we create the highest value, the highest quality, and at the highest pace, or the fastest pace. Right? But the reality is, oftentimes we're not in that flow, right? We have a lot of waiting in place. We have a lot of context switching. Troubleshooting is inefficient. We do a lot of Googling to find answers, and we make a lot of decisions based on gut feel. Right. So it is fair to say that the toolchain behavior is a major contributor, but also inhibitor to developer productivity. So let's look at it just for a second in a bit more detail. Right? You're building your software, you made a change, you want to see if that change is sound. It could be in the IDE, it could be on the command line, or you ask CI to run your build, and now you need to wait. It just takes too long to get that feedback. You might make a little change, but you have a long wait time. Right? I think we all experience this oftentimes. Or something is broken, and now it takes a really long time to fix it. Right? You're making a change, and you run the build, a test fails, and you're like, oh no, okay, here we go again. Right? And you start investigating, and sometimes, yes, it's a direct correlation between the change you made and the error you see, but it's not always the case. For example, let's say you build, everything's fine, you make a change, you build again, and now tests are failing. And it turns out it's because you pull in a new version of a snapshot dependency. Right? Really hard to find out. Right? The second or the third category of friction that we see is, again, let's come back to tests. You run a test, it fails, you investigate, and hours later you figure out, oh, it's a flaky test. It has nothing to do with your change. And you could have figured this, you should not have had to figure this out, because this test has been flaky for maybe 3 weeks already. Right? It has been known, but it has not been observed, it has not been surfaced. Right? So again, you wasted time. And all these frictions makes you slower in delivering features, and typically the quality is affected too. You multiply that over the year, and with all the engineers on your team, could be an open source project, could be a commercial product or project, doesn't matter, and it means a lot of costs, a lot of waste, and the reduced productivity. And this is really a problem, right? GitHub did a survey last year, or I mean, they do one every year, but they asked, like, what is most time-consuming in your work? And besides writing code, it was waiting for code to build, right? And if you think about it, it's quite ironic. I mean, developers are well-paid engineers, and a big part of their salary goes to waiting, right? Meaning features are not delivered as fast as they could, patches don't go as fast as they could, and so on, because people spend so much time waiting. Right? So let me come back to that question that I asked before. What do these common foundations have in common? And it is that they're all using Develocity. Right? That is a platform, a developed productivity engineering platform that I will explain a bit more in detail. So Apache with 350 projects, all the projects can use Develocity. I'll show you more details in a second. Micronaut as well, they have more than 80 projects. They're all using Develocity. Common House is kind of starting to grow. They're also benefiting with their projects as well as the Spring 40 to 50 projects. Right. So, but here we are at EclipseCon, right? So the good news is that there is a really good chance that Eclipse will also have, or the Eclipse Foundation will also have Develocity available to all the projects, right? We're currently working with the Eclipse Foundation to make that work, such that Eclipse would host an instance, and then all the Eclipse projects, or part of the foundation, could connect to the instance and benefit from everything that I'm going to show you. Right. So, just in a nutshell, what is Develocity? It's a platform, and it gives you deep insights what happens when you run your build, whether it's locally or on CI. So not just CI, as important, also your local builds. And it can also make your running your build faster via acceleration technologies. You can use the insights or just the acceleration, or both. Of course, using them together is best, but it's in the end up to each project what they decide to use. And even though I'm from Gradle, it doesn't mean this is all for Gradle builds, right? It's really important we have the same support for Maven as well as for Bazel and for SPT and soon for NPM as well, right? So everything I explain universally applies to these different types of build tools, right? And what does it mean when using that platform? Basically, you have a project, you apply a plugin, or with Maven an extension, you point to the server, the Develocity server. In this case, it will be develocity.eclipse.org. And from then on, every time you're on a build, metrics about the build are captured, stored on the server. You can visualize them there. You can aggregate them. You can export them and work with that data, right? And I'll show you more details about that in a second, right? So that's in a very, in a nutshell. So let's look at the build insights part first. And let's start with this idea. You're coming to EclipseCon here, you're flying with your private jet here, and you have a choice, right? You could have instruments that look like this, or you could have instruments that look like this, right? And which one would you choose, right? And I would assume most people would pick the second option here, right? Because if something goes wrong while you're in the air, you want to be in the best position to understand what's going wrong so you can make a quick decision to fix the situation. Right. You also want to know if things are well or if they're not well. Right? And if they're not well, you want to react quickly. Right? So having information, actionable information available that you can then make based decisions on is really crucial. And it's not only with flying, it's also with building software. Right? So with Develocity, as I said, when you connect your build and you run your build, it will capture data about what happens in the build, nothing what else runs on your machine and so on, just what happens in the build, and sends that to the server. So there's nothing personal, private in there, right? But as I said, it works on CI as well as on local builds. So, for example, what dependencies were resolved. And that is not always straightforward. You cannot just go to your POM XML typically, because you might have conflicts of versions. Which one was picked? You cannot, that's a runtime information. You cannot derive that statically from some files. Right? Or it would at least be super, super hard and take so much time that, again, it's inefficient. What goals did even run? Right? What tests were executed? Which ones were skipped? How long did they take? Which plugins were applied? Which flags did you run the build? This is all, and so on. This is all information that really surfaces what happened in the build. And especially when things don't go right, it's very helpful to have that information available to quickly come to the source of the problem, either yourself or by interacting with a colleague. Right? Let's say you run the build on CI, it fails, and what you do typically now, you probably just tell the CI person, hey, the build fails, it's your problem, it's your fault. Right? And the CI team will say, well, I don't know, this is not my problem, it's yours. Right? So there's all this back and forth, very inefficient. Whether it's a commercial company or it's an open source project. But if you have the insights available and they're surfaced, you can decide yourself, or with the help of a colleague, okay, this is the root of the problem, and then typically addressing it is the easy part, right? But understanding what's going wrong, what's happening, is the difficult part. Right? So all this richness of information is there, whether it's a Maven build, a Gradle build, SPT, or Bazel build. Right? So it becomes very actionable. Another area, and I'm sure everybody has this problem, is flaky tests. Right? And so we can also surface that. We've seen projects, they said, no, we don't have flaky tests. But once you connect the builds, it's like, okay, you do have flaky tests. But most companies are aware, we have flaky tests. But then most companies also, or projects, have more flaky tests than they have time to address. So how do you prioritize? You need to know which ones have the most negative impact. And that's also something we can surface. So if you have one flaky test in a project that runs every 4 months, versus another flaky test that runs on a build, or on a project that is built hundreds of times every day, well, it's pretty clear where you're going to prioritize your investment. And we can also, as I said, we can prioritize or give you a prioritized list. You can also see, when did that flakiness arise? When did it drop? Or did it drop because you made a fix? It's not always clear that making a fix is actually fixing the flakiness, right? Sometimes you have a good idea, like, yeah, this is probably, but you want to see the confirmation. And we can also show this graphically, so you can confirm, yes, we addressed it, it's now gone. Right? And then something else surfaces to the top. And that is then the next thing to address. Right? So flaky tests, very painful for every project, can be tackled more systematically and more based on data than before, where it was just typically gut feel. Yeah, it's probably this test that has the most impact. And typically that gut feel is based on what happened most recently, right? This test failed yesterday, well, let's fix that one, versus the one from 2 days ago, even though that one might have more negative impact than what happened yesterday or today. We can also surface insights about tests that executed, but it was not necessary to execute them because they were not affected by the change. Right? And we can see that here, right? With a simulation, we can see, there were a lot of tests executed, even though they were not affected by the change. And we can do this based on historical data to which a machine learning is applied that then says, for this given set of changes, we only need to run these tests instead of running all the tests, right? Because typically also when you make changes, they are local. They're local in their impact, but also local in the impact on the tests that test them, right? And so that's another area where surfacing this information can help avoid running unnecessary tests. There's more we can surface, and I don't want to cover this all, but also understanding things like, what type of failures do I have on CI? Or what type of failures do I have locally? If you're on a project, on a team, it's very hard to know what's happening locally because developers might not tell you, right? They're very, I'd say robust against problems, so they just work around it. And they might never tell you, Docker never starts up the first time when I run the build, so I need to rerun it. But if you have the builds captured where this happened, you can see, we have a lot of these types of failures. Well, let's do something about it to improve the situation. Right? So surfacing failures, classifying failures is a very impactful way to improve the stability in that sense, the productivity of your team. Right? There are other areas, but I'll keep it at that for now. Okay. Now, let's say you're on a platform team, an infrastructure team that manages many projects. Right? Let's say the Eclipse Foundation, hundreds of projects, and they want to improve what's happening on CI. For example, let's take failures. They want to have less non-verification failures on CI. They want to do something about it. Where do they start? Right? If you aggregate the data from all the projects by certain dimensions, you can make informed decisions. You can say, this project has a lot of failing builds in total build time. So let's take that one first versus another project that has a lot less build volume of failing builds. Right? So again, you get the most return for your investment. And we can do this by aggregating the data from all the builds and then basically grouping it by project and looking at it from different dimensions. Failures, build cache hits, whether they're using certain flags that maybe they shouldn't, maybe they're always resolving dependencies on each build, which can be very expensive, right? All these things we can surface, group, and then decide, okay, this is the most impactful area to address first. The other area that I mentioned, besides build insights, is build acceleration. Right? It's good to surface things and make them more stable, but the other area is actively making things faster. Right? There are a lot of things that come with making things faster, so I'll not go through this diagram in detail. But having less wait time in the end leads to higher quality. You build more often, smaller change sets. It's easier to find the cause of a problem because the change set is smaller, and so on. Right? So a lot of downstream benefits of having faster feedback cycles available, whether it's in your IDE, building locally on the command line, or on CI. Right? Develocity will give to all these projects that connect 3 acceleration technologies: build caching, predictive test selection, and test distribution. Build caching, what it does is it tries to, or it does avoid rerunning work that has been done before on the level of a goal in Maven or a task in Gradle. Right. So if you run the build twice and the input that goes into a certain goal has not changed, it will not rerun that goal, but it will just take the output from that goal. For example, compilation, you didn't change the code to compile, you didn't change the flag, the Java compiler version, and so on. Well, instead of rerunning the compilation, it will just take the compile classes from a cache and reuse them. Right? It can do this locally, it can do this on CI. Right? You can turn this on for certain goals if you want to, or for the entire build, but ideally it's turned on for all the goals that support this, and the same for Gradle with tasks. Right? And so the concept of not redoing work that has been done before is very powerful. Because typically, like I said before, when you make a change, the change is very local. So if I make a change in one module, in one test, there's no need to recompile the entire project. Right? And it doesn't have to, because it can reuse the outputs on a single goal. Not on a module, but on a single goal. Now Maven also has a cache with the new version, the 4 version, where it operates on the level of a module and not on the level of a goal. So with this cache, and you can even use them together, right? They're not competing with each other. But the benefit of doing it on a goal level is that, or a task level, is that even within one module, you don't need to redo everything, right? One change you make in that module might mean, oh, I need to redo Javadoc, but I don't need to rerun the tests. Maybe the only change you made is an annotation in a Java comment or in a comment, a Javadoc comment that does not affect running the tests. Right? Maybe you change the author or something like that. Okay. Predictive test selection, that is what I mentioned before. So Develocity can take a change set, and before running the tests, it can determine, based on the history, which test should it actually run. And the other ones it will skip. Right? And then it will just run those tests. Now, some people say, oh, but in the end, I want to run all tests. I want to have the confirmation that everything passes, because no prediction model is going to be 100% perfect, just like the weather will never be predicted 100% correctly. Yes, that's true. So there is a mode where you can say, okay, let's only run what we determined is necessary based on the change, but later on in your pipeline, maybe at the end of the pipeline or at merge time, you can say, let's run the rest of the tests that you haven't run yet for the same changes. So in the end, you still run all the tests, but in your daily feedback cycle or hourly, monthly, minutely feedback cycle, you will only run those tests affected by the change. Right? So you basically get the best of both worlds. And then test distribution will take the tests that need to be run, either all tests or if predictive test selection says only a subset, and distribute them across multiple machines. So not just multiple processes on the same machine, but actually physically different machines. And of course, you get parallelization is a great way to improve the feedback cycle, because it can run those things together. It can also balance the tests, so they all about finish at the same time for each machine or each node, and we get a great boost from that as well. Now, you can combine those technologies together, and then you really get more than the sum of the parts. Or you can use them individually. Right? Some people say, caching, yes, but we're not ready for test distribution. Or they say predictive test selection, we don't want to use it, but we still want to use test distribution, right? So you can really pick any combination of these technologies together. And you can do that on a per project base, right? It's not like everybody at Eclipse would have to use the same approach. I just want to finish this part by giving you some concrete data. So the Spring Boot project, they're using Develocity intensely for a long time already, several years. Within 7 days, they're saving 19 days in task execution time due to caching. So that's 19 times 24 hours. By not doing work that was already done before, by a different CI build, maybe on the same branch, on a different branch, yesterday, 2 days ago, doesn't matter. Right? Just through the caching, they can reuse the work and can basically save that work or save that time to run it again. And so as a consequence on CI, instead of the build running on average 55 minutes per build, it only takes 23 minutes. Right, so, which is a substantial improvement when you think you make a change and you want to know whether that change is good and you want to run it through the CI pipeline. Right. And oftentimes it's even faster than that. This is really just the average. Another project, I wish I could use Eclipse project, and I hope I can use that next time if I'm here again. Right? But for now I have to use projects from different foundations. So Apache Beam is a very active project. I have a lot of developers working on that full time from what I understand. Within a week, they could save 27 days. So 27 days times 24 hours in serial test execution time if they apply predictive test selection. So the result you see here is from a simulator that we have built in. And it will tell you, well, if you turned this on, we would not have run all these tests, and this accumulates to 27 days in test execution time. So substantial time, both from a resource consumption, which resource consumption means costs, but it also means these resources were used and could not be used for something else. Right? So other projects will have to wait, or even the same project will have to wait to build something else. Okay. And the third one, that is actually from an Eclipse project, is from the Jetty project, where running the test takes about 47 minutes. And with the help of test distribution, we got it down to like 60 minutes. Okay. You do some additional enhancements to the entire build, you get it down from 51 minutes for the entire build to about 11 minutes. Right. And the build still does the same thing, right? We're not making any functional change here. We're just applying these acceleration technologies, using some of the insights to make further improvements, and that's where we get it down to. Right? So that means you make a change, and to run the full build, instead of waiting 50 minutes, you wait 11 minutes. And that's the full build. So of course, if you work on a project, you typically wouldn't even run a full build. Okay, so everything I mentioned here applies to commercial projects that you maybe do during your day job, as well as to the open source. Right? And the important part here is that as developers can choose what open source projects they want to work on. Right? They can choose it based on very different criteria. Right? And one of those criteria is the developer experience they will have. Right? How easy is it to build and test and run the project? How easily can I solve if I have a problem? Right? How easily can I unblock myself? Right? And how effective is it to collaborate with committers? I mean, I've seen so many projects where people tried to build it, they couldn't, and they were asked to send logs via email, so they didn't have to put them in GitHub comments, and so on, right? Or people just give up. They're like, oh, I tried to build it, it didn't work. Okay, I'll move on to the next project. Or they try to build it and it takes 3 hours to build the project. I mean, even Spring, it takes close to an hour to build the full project, the Spring Boot project. Right? So do I really want to go through that process if all I want to do is make a small change, a small contribution, and it's my first one? Well, maybe I just move on. Right? Example, again, I can check out Spring Boot now that they're using build caching for a while, and it builds in just a few minutes. And if I have the dependencies already cached, it's literally a matter of seconds. Right? So that means I see a bug, I want to fix it, I check out the project, I run it, and within a few minutes, I have built the project already locally, and I can jump on making the change. I'm not spending hours trying to or waiting for it to build until I can actually make that little change that I want to make. Right? So the hurdle goes way down. And if something goes wrong, I have that build scan, which is that visualization of what exactly happened in the build that I mentioned, with the dependencies, the plugins, the goals, and so on. And I can use that to oftentimes find out myself what was going wrong. Right? And if I can't, I can also share that build scan and say, hey, here's what I did. Can you please help me resolve the problem? And they might say, oh, okay, yes, I see this was what's going on. Do this, and now it's working. Or maybe they have to fix something on the project side. Right. Flaky test, same thing. This can be really problematic, right? You make a contribution, you run the build, and now it fails. And now the contributor says, no, we cannot integrate that change because you made the build fail. Well, it could be a flaky test. And it's not even and it could be a flaky test not related, not even written by that contributor, right? But he's now the poor guy, or the poor woman, who will not get the PR in. But if you knew that it's a flaky test, as a maintainer of the project, you can handle it differently. Right? You could even automate it and say, "Oh, I know this is a flaky test. Let's handle with it to a different workflow." Right? So very important, also what we see from practice, to attract but also retain contributors by giving them a first-class developer experience and not making them too frustrated so they move on. And as I said, we know this from experience. Right? We have these foundations that we interact with, but we also have other projects. The JetBrains Kotlin project, they're using Develocity and they're benefiting from all the things I mentioned. The JUnit project is also benefiting from that. Quarkus, Hibernate, and so on. They're all benefiting from the things I mentioned around insights as well as acceleration. So what could be the next steps if you're working on an Eclipse project? I mean, you can visit us at the booth that we have here and tell us what you're working on, what your pain points are, how we can help. You can also get in touch with the Eclipse Foundation and ask them to connect your project. I mean, they have a staging server set up, and the next step is now really to finalize that so all the projects can get connected. But they're always looking for some, let's say, guinea pig projects to try it out. But it's not like, oh, at your own risk, this could break your project or so, right? It's more like, okay, let's get some more experience from Eclipse project as well. And if you want to know more about developer productivity engineering in general, there's a DP University where you can take free classes and learn more about DP, Develocity, for Gradle, for Maven. There's even a course on Maven build caching, and so on. All right, and that was it. Thank you very much for listening. If you have questions, you can come up to me, right?